All right, so this is 5.2, number 5. So I said you could either use the quadratic formula or you could solve by factoring, so up to you. But number 5 is b squared minus 4b plus 3 equals 0. So if you solve by factoring, because our a is 1, remember ax squared plus bx plus c, so our a is 1, our b is negative 4, our c is 3. But yes, because a is 1, we can just write b times b to create that b squared. And then we've got to think what multiplies to create 3, but adds to create negative 4. And so that's negative 3 times negative 1. And then we'll just use the zero product property and solve. All right, so our answer will be b equals 3 and b equals 1. Now, if you prefer, let me show you real quick. If you prefer to do the quadratic formula, though, and some of them you do have to do the quadratic formula, just let me remind you, x is equal to negative b. So because our b we talked about was negative 4, a negative b would give us positive 4, plus or minus the square root of b squared, so negative 4 squared is 16, minus 4 times a, 4 times 1 is 1, and then 4 times 3 is 12, all over 2a, our a is 1. So then we do 4 plus or minus the square root of 4, 16 minus 12 is 4, over 2, which would be 4 plus or minus 2, square root of 4 is 2, over 2. So we have 4 plus 2, which is 6 divided by 2, which is 3. Then we have 4 minus 2, which is 2 over 2, which is 1. So we'd have x equals 3, x equals 1. So either quadratic formula or factoring for 6.2. All right, then you asked about 5.4. So switch gears now. 5.4, we're building polynomials. So let me pull up those problems real quick. You asked about number 9 through 12. So these include, 9 through 12 include some radical and some imaginary. And so what you need to remember is that just like we had the plus or minus when we were doing the quadratic formula, or when we were solving by factoring, we had two answers. Whenever you have a radical, for every positive radical, you'll have a negative radical. So we have root 2, that means we have root 10 and negative root 10. Now look at 11 real quick. With that imaginary, I already included all of them. So you have 2i, negative 2i, negative 3i, 3i. I'll go over that in real quick, but just notice that, just make sure, because when we use the quadratic formula, and these imaginary and these radicals only show up with the quadratic formula, you always, always, always have plus minus. So we have plus minus. All right, so what we do now is we're going to have to multiply these, and always, always, always multiply the pairs. They're called conjugates, so always multiply those together. And you're going to notice something real nice is the middle term will always, and I kind of wrote that weird, usually we'll write the x, anyways, it doesn't matter. But the middle term will always cancel out. So then we have a positive times a negative, and we have root 2 times root 2, right? Okay, so middle will always cancel out, and we'll have x squared minus, now root 2 times root 2, if you put that into your calculator, you're going to get 2. Why do you get 2? Is because a root 2 times a root 2, 2 times 2 is 4, square root of 4 is 2. Okay, now that's only half of it. So we need to do the same thing here, x plus root 10 times x minus root 10. Now I'm just switching the symbol, right? But just noticing that how I go to the factor, just like you did in the others. But you're going to notice a trick. Whenever you have conjugates multiplying, you can just think of it as a squared plus b squared, and you don't have to do the whole process. So I say, all right, my a is, sorry, not plus, it's minus. Because that positive times that negative. All right, so you look, our a is x, so we're going to have x squared, and then our b is 10. So if we do 10 squared, we're going to get rid of that square root, and we'll have 10. So we could have used that trick in the first part, x squared, square root of 2 squared, cancels it out, we just get 2. So, I mean, I wanted to show you how to do it, but you can save a little bit of time. Okay, so we're creating a polynomial, so we're still not done. We just have two binomials here, so we got to multiply those. And we're going to get x to the fourth minus 12x squared plus 20. Okay, so that's what you're going to do on 9, on 10, let's see, and then 15. So 15 you have negative 4, 4, then you'll use root 6 and negative root 6. So, but you'll just multiply them like that, okay? All right, so then, and if you still have questions, just email me. Then let's talk about imaginaries real quick. Okay, so with the imaginaries, let's do 11. All right, so you have negative 2i, 2i, negative 3i, 3i. All right, so you don't have to, I gave you the positives and the negatives, so you don't really have to think too much about that. But when we take them to the factors, they will be conjugates. So I'm going to do this one first. So remember the trick, we could multiply it, but the trick is, okay, so yeah, I'm just going to multiply it. But you know the trick now, so just watch real quick. Okay, so 2 times 2 is 4. Well, then positive times negative is negative. 2 times 2 is 4. I times I is I squared. So we have x squared, middle cancels out, and then we have minus 4i squared. Now, we're not done with that I squared. I'm going to show you what happens. Give me a second. But don't forget the trick. If you have conjugates multiplying, it's going to be a squared minus b squared. So let's just analyze it. Instead of doing what I just did, we could have taken x squared, and then we could have taken 2i and square it. So 2i squared, like we talked about, is 4i, and then the negative in the middle. Okay, now we're not quite done with this I, though, because we got to remember I pops up whenever we have a negative under a radical. Or sorry, yeah, negative under a square root. So if we square both sides, that's going to cancel that out. So I squared is actually negative 1. So that's actually negative 1. Negative 4 times negative 1 is positive 4. Okay. Now, looking at this, we're going to have x plus 3i, x minus 3i, which means that we're going to have x squared minus 9i squared, but I squared is negative 1, so we'll have x squared minus 9 times negative 1, which is positive 9. And then we'll multiply those together. And these aren't conjugates, so you actually have to go through and multiply them, and then you'll get your final answer, which is x to the fourth plus 13x squared plus 36. So hopefully this helped. If you still have questions,